Okay, guys, welcome. Today we're going to talk about using the quadratic formula to solve a quadratic equation. So in the last video, we talked about how to use completing the square to solve a quadratic equation that you cannot solve with factoring. Another method that we'll use to do so is what's called the quadratic formula. So what's nice about the quadratic formula is that you can solve any quadratic equation in this form. So if we consider our x squared coefficient to be a, our x coefficient to be b, and our constant is c, as long as everything is on one side, we can substitute it into this formula to arrive at a solution. So let's look at an example of that in action. So the first one that we're going to look at is x squared plus 5x minus 6 is equal to 0, and we're going to solve it with the quadratic formula. Now again, this is another one that you could use with factoring, because you would need two numbers that multiply to -6 and add to a +5. So of course you could factor that as x plus 6 and x minus 1, and if you want that to equal 0, you would get that x is equal to -6 and also to 1. So we know what we should get for an answer, but let's take a look if we use the quadratic formula and see what happens. Right, so the quadratic formula, we need a, and we need b, and we need c. And in this case, my a is 1, that's my coefficient of x squared. My b is 5, that's the coefficient of my x. And my c is -6, the coefficient of, or just my constant term. So to get x, I need -b plus or minus square root of b squared minus 4ac over 2a. So the first thing that we need to do is just plug in the values that we found. So we have a negative b, which is 5, plus or minus square root of b squared, so 5 squared, minus 4 times a, which is 1, times c, which is -6, all over a 2 times a, which is 1. So now we just need to simplify. So a negative in front of a 5, we can just make that a -5. And then we have plus or minus 5 squared is 25. And then this -4 times 1 times -6, once we multiply them together, we'll get a plus 24. And then all over 2 times 1 is just over 2. So of course, 25 and 24, we could combine that to be a 49 over 2. And the square root of 49 is just 7. So of course, we get two answers here. We get -5 plus 7 over 2, which is a 2 over 2, which is a 1. So that's one of our x values, which again is something that we should expect. And the other one is -5 minus 7 over 2, which is a -12 over 2, which is -6. And of course, these are our two x values, and they match what we got before. So that's good. So that's what we would expect. Let's check out another example. Okay, so in this example, we don't have everything on one side, so we want, of course, to do that first. So I'm going to add the 25x squared to both sides. And if we do that, we have that 0 is equal to 25x squared plus 10x plus 1. Now, in this example, this is a good sort of indicator, or not, I guess not an indicator, but more of an example of when you don't remember how to factor this, you could use a quadratic formula to solve it instead. Because in order to factor this, you would need to do 25 times 1, which of course is 25, and you need to break that into 5 and 5, and so on and so forth. And usually a lot of people don't remember this process, but what they do remember is the quadratic formula. So this gives you another option to solve something like this. So in this case, our a is 25, our b is 10, and our c is 1. And in the quadratic formula, we get x is equal to negative, and I'm just going to fill it in this time. So negative b, which is negative 10, plus or minus square root of 10 squared minus 4 times a, which is 25, times c, which is 1, all over 2 times a, so 2 times 25. Okay, so now we just have to simplify. So we have a negative 10 plus or minus 100 minus 100, actually, over 50. So this will actually go away because this is just 0. And plus or minus 0 is still the same thing. So here we get minus 10 plus or minus 0, so we don't need it, over 50, which is just a negative 1 over 5. So in this case, we actually only get one solution. We get that x is equal to negative 1/5. And of course, this would make sense because if you choose to factor this, and it might not be a bad idea to refresh how to factor this, but if you factor it, what's going to happen is that you could break this into 25x squared plus 5x plus 5x plus 1 equals 0. And once you factor by grouping, you're going to get a 5x times 5x plus 1 plus 1 times 5x plus 1. So you get 5x plus 1 squared is equal to 0. And if you solve that, you do get the negative 1/5. So of course, you could do that either way, but again, we just show the quadratic formula here. Okay, now I want to look at one where we have fractions, because you could do one of two things. If you keep it as is, then your a is 1, your b is 1/3, and your c is 5 over 6. And this is going to be quite some work in the quadratic formula. Because the problem with this is that now you're going to introduce fractions within a fraction within a square root. So you're going to make this a little bit more complicated by using the fractions. Now, one thing that we can do instead, you can multiply by the LCD in this equation so that you don't have fractions anymore and use those values. So we're going to multiply by the LCD to clear the fractions. So if we do that, in this case, I need the LCD of my fractions. So the first one doesn't contribute anything. And if I look at 3 and 6, my LCD, of course, would be 6. So if we multiply the original equation both sides by 6, we're going to get a 6x squared. And then if I do 6 times 1/3, I'm going to get I'm going to get 2x, right? If I do 6 divided by 3, that's 2. 2x. And if I multiply 6 by 5 over 6, the 6's will cancel, and I will get 5. And of course, 6 times 0 is still 0. So now my a is 6, my b is 2, and my c is 5. So this will make our time in the quadratic formula much easier because now we don't have to deal with fractions. So now we get a negative x is equal to negative b, which is 2, plus or minus b squared, so 2 squared, minus 4 times 6 times 5, right? Minus 4ac, a is 6 and c is 5, all over 2 times 6. So now if we simplify, we get a negative 2 plus or minus 4 minus, and then I have a 4 times 6, which is 24. And if I multiply that by 5, I believe that would be a 121. You can also do 4 times 5, which is 20. So we actually get a 120. Sorry about that. So 120. Okay, and then all over 2 times 6, or 2 times 6, which is 12. So now if we simplify this a little bit more, we have -2 plus or minus a minus 116 over 12. Now 116, off the top of my head, I'm not so sure what that comes out to be, but I suppose that we could factor that into, let's see, let's take out a 4, because I know we can do that. And if we take out a 4, I believe if we do 4 times 25, that would be 100. So if I do 4 times 26, that's a 104. So it looks like we need a 29, right? So we could write this as a 2 square root of 29. So now, and again, since down here it's a negative, I'm going to need 2 plus or minus I, or let's say 2 square root of 29 times I over 12. Now, one last thing that we could do in this case, since we have a complex number and we can't add our imaginary and real parts, the last thing that we might do is divide everything by 2 and say that we have a -1 plus or minus square root of 29I over 6. So in this case, we get 2 complex solutions. All right, so that's what we've done so far, sort of represents the 3 different possibilities as far as solution types. You can either get 2 real numbers, you can get just 1 real number that results from having a 0 inside that square root, or you could get 2 complex solutions, which represents a negative in that square root. Okay, now what I want to do next is I want to look at an interesting sort of question that does come up that we can now sort of have the power to look at. Now, in this case, we're sort of going in the reverse direction. We want to determine an equation that has specific solutions. So in this first example, we want to come up with an equation that has -3 and +2 as its solutions. So essentially, the easiest way to do this is to rig it so that it has to be true. If I want -3 to make this work, then I make a factor of x plus 3. So that way, when I plug in -3, I get -3 plus 3, which is 0. And for x equals 2 to be a solution, I would need x minus 2 to be in there. And now, if I plug in 2, this is 0. If x is equal to 2, you get 5 times 0, which is 0. So that's good. And if x is -3, we get 0 times -5, which is also 0. So now at this point, we could just FOIL this out, and we could say that 0 is equal to x squared if I distribute the x's, and that'll get a -2x plus a 3x, so plus x, and then -6. So it turns out that if we, as long as we basically control what our equation looks like, we can make it have any solutions that we want. And that's no different for the complex case. We would just need to do x minus 2 plus I times an x minus 2 minus I. And of course, we could FOIL this out just like we did before. And if we do that, we will get x squared. Now here, of course, we have to be a little bit careful. And in fact, let me write above here that you have x minus 2 minus I, if you distribute that negative. And this one would be an x minus 2 plus I. So the x times x is x squared. Then we get minus 2x and a plus ix. And then we get a minus 2x again, plus 4 minus 2i. And then finally, we get a minus ix again. Let's come over here. Minus ix. And we get a plus 2i. And then we get a minus I squared, which of course we know is minus a negative 1. So these ix's cancel, these 2i's cancel. And it looks like that our equation, when all is said and done, will be an x squared. And then my two x terms are minus 2x, so minus 4x. And then I have this minus negative 1, which is like plus 1. And then we get a plus 5. Okay, so that is the equation that will have these two as solutions. Okay, so that's sort of an interesting type of problem here. Now, one thing that we mentioned earlier was that depending on what happened underneath the square root, we got different types of answers, right? So in the third example we did, let me just come back to here. In the third example, we had a negative in our square root, which gave us two complex answers. In our second example, we had 0, so that gave us one single real number solution. And in the first one, our square root was positive, so we had two different real number solutions. And that's what this is saying here. So the discriminant is just what's underneath the radical sign in the quadratic formula, right? That b squared minus 4ac. If we look at x, it's negative b plus or minus square root of b squared minus 4ac over 2a. We're just picking out what's underneath the square root, and we're calling it the discriminant. Now, depending on what that comes out to be, that's what's going to dictate the type of solutions that we have. So this is just sort of summarizing. Actually, let's do it this way. This is summarizing what we just said a minute ago. If what's underneath the square root is positive, you have two real number solutions. If it is 0, then you have a single real number solution. And if it's negative, you have no real number solution. You have two complex. All right, so let's see what we can sort of apply that to. Now, in this example, we just want to figure out what the solution types are going to be. So all we need to do is we need to look at b squared minus 4ac. We need to figure out what would be underneath a radical. So in this case, my b, let's start with a. In this case, my a is 1, my b is negative 5, and my c is negative 14. So if we look at b squared minus 4ac, that's a negative 5 squared minus 4 times 1 times c, which is negative 14. So we get 25. And then negative times negative will be a plus. And then 4 times 14 will be a 56. Right, so at this point, we can see that it's going to be positive, but just for completeness, we'll find it. I believe it's an 81. And since this is positive, this tells us that we have two distinct or two different real number solutions. So without even solving it, we know what type of solutions that we're going to get. So that's one interesting thing. All right, if we look at another example, we have that a is equal to 3, b is equal to negative 2, and c is equal to 8. So again, we're not concerned with the actual solution. We want to see what type of solutions we have. So if we look at b squared minus 4ac, we'll get a negative 2 squared minus 4 times 3 times c, which is 8. So we get a 4. And let's see, we get a minus 32 times 3, so a minus 96. So this will give us a negative 92, which of course is less than 0. So since we get a negative number here, we're going to have two complex number solutions. Okay. One last thing in this video, we're going to talk about a specific application problem, which is a sort of a physics application, and we're going to look at projectile motion. So you can represent an object that is originally projected upward, you can represent its position or its height above the ground by this formula here. So that's what we're going to look at in a second here. So for example, we're going to let our equation be h minus 16x squared plus 40x plus 50. And we're going to solve a couple problems based on that. So the first part of this problem is we want to know how long after the ball is thrown will it be 30 feet above the ground. Well, what we can do is if we want the height to be 30, we just set h equal to 30 and solve for x. So then we get 30 is equal to negative 16x squared plus 40x plus 50. Well, now this is something that we can solve. We can move the 30 over, and we get that 20 is equal to negative 16x squared plus 40x. Sorry, this is not there. This should be 0. Plus 20 on this side. One thing that we could do that would make our life a little bit easier is to factor a 4 out or divide both sides. Let's divide by negative 4. And we get 0 is equal to 4x squared minus 10x minus 5. So now we could not do this at least right away with factoring. It looks like we can't factor it actually. So we can use the quadratic formula now that we know it. So our a is 4, our b is negative 10, and our c is negative 5. So in the quadratic formula, we get x is equal to negative 10, negative 10, plus or minus b squared, so negative 10 squared, minus 4 times a, which is 4, times c, which is negative 5, all over 2 times a, or 2 times 4. So we get a positive 10 plus or minus 100. And let's see, I guess we get a plus 80, it looks like, over 8. So we get a 10 plus or minus square root of 180 over 8. And I believe that we could take a 36 out. I believe if we do 36 times 5, that should give you 180. Let's just check that real quick. Well, that won't work, right? So let's do 180 divided by 5. And we'll get a 15, we'll get a 3, we'll get a 0. Yeah, so we do get 36. So we could say that this is 10 plus or minus 6 times square root of 5 over 8. And if you don't have a calculator, the best you could do at this point is to just divide top and bottom by a 2. And we get that 5 plus or minus 3 square root of 5 over 4 are 2 solutions as to when the object will be 30 feet above the ground. And of course, if you wanted the decimal version of that, you could use a calculator to get that. Now, when will the ball strike the ground? Ball strikes the ground when the height is 0, of course. So we want to solve the original equation for when h is equal to 0, which just makes this 0 is equal to negative 16x squared plus 40x plus 50. I believe that's what the original one was. Yes. Okay, so again, in this case, I believe now we can only divide by a negative 2. So if we do that, we get 0 is equal to an 8x squared minus 20x minus 25. So now my a is 8, my b is negative 20, and my c is negative 25. So in the quadratic formula, we get x is equal to negative 20 plus or minus b squared, so negative 20 squared minus 4 times 8 times c, negative 25, all over 2 times 8. So it looks like we get a 20 plus or minus. Now 20 squared is a 400. And then it looks like we have negative 4 times negative 25 is positive 100. And then we get a times 8, so we'll get a plus 800 over 16. So it looks like we get that x is equal to 20 plus or minus square root of 1200. And we should be able to factor out, sorry, this is over 16. We should now be able to factor out a 400 out of that. So we'll get 400 times 3, square root of 400 is 20 over 16. And again, without a calculator, the best that we could do here is we could take a 4 out of the top and the bottom, and we'll get a 5 plus or minus 5 square root of 3 over 4. Now, of course, here there's a problem because one of these answers will be negative. 5 plus 5 square root of 3 over 4 will be some positive number, and x is equal to 5 minus 5 square root of 3 over 4. This is going to be some negative number. So we want to throw this one out because we know that we can't have negative time in this problem. So in this case, we actually only get one answer. So we get 5 plus 5 square root of 3 over 4 is when the object will hit the ground. Okay, so that wraps up this video on looking at the quadratic formula and some applications. So I hope you enjoyed, and I will see you next time.